if there is deflection here, set it to 1K. We have here 1K. Okay. It turns on actually. Turns on. This negative side is actually connected to the emitter, to this terminal here. Emitter number 3. And the positive side is connected to the collector here of this optocoupler. So, there is deflection. But once this is disconnected, there is no applied voltage to the light emitting diode here. So, there is no deflection. So, this phototransistor conducts if the LED is supplied with voltage and it gives light. This transistor is a phototransistor which can be energized by the light submitted by the LED. Actually, the LED here is sometimes infrared LED. Infra LED. Meaning to say that although the voltage here is forward bias, for example, let us apply this with voltage using, okay, where was that voltage? Okay, we will use again times 1 ohm range to measure the two types of light emitting diodes here. So this light emitting diode, once it is supplied with voltage from the ohmmeter, it gives light. Light emitting diodes will convert the electrical energy here from this battery to electromagnetic radiation into light at visible range. We have here. So, internally, actually, this optocoupler uses sometimes LED that emits light at visible range. But if in case it is an infrared LED, it deflects the pointer, but you can't see any light because the light is invisible. That's why it is called infra, meaning below. Harder or the redder is the visible range. So, below the visible range, there is light emitted, but it is beyond the visibility of the human eyes. But with the use of cellular phone, you can see the flickering light. For example, of your remote control. Okay? There are two types of LED being used by the optocoupler. Most often times, it is an infrared LED, wherein the phototransistor is sensitive to that infrared or infrared light. No? Okay. So, there are actually two light emitting diodes being utilized by the optocoupler. So, again, optocoupler here is a semiconductor device that transfers electrical signal here to the opposite side of the circuit by means of light. So, what is being transferred here is the feedback signal. The sense change of voltage here, because there was a change of voltage here being detected by this precision shunt regulator being compared to the reference 2.5 volts here. Then there's a difference. So that error 0.5 difference will be amplified before it is submitted to this optocoupler. This diode actually will drop 1 volt. Okay? So, what is being dropped here? And the current also here is varied. It is varied from 100 milliampere to 150 milliamperes. That depends upon the feedback. Sometimes the voltage here negative or positive. Let us say, it becomes, let us say, 4 volts at the output. So, meaning to say, 2 volts and 2 volts. That makes it 4 volts. So, 2 volts, then the reference here is 2.5. There's a difference again. Negative 4 or negative 0.5. Diba? Because 2 volts, then this is 2.5 volts. Reference voltage is much bigger. So, negative feedback that will be sensed by this sensor here, then submit it to the control voltage IC through optocoupler. Okay, it goes like this, class. Okay, try to observe this one here. There are two coils actually here. There are two coils, primary and secondary coils, which are not physically connected. But, okay, we have here, observe the light here. Okay, once it is put closer to the primary here, it gives light. See? Although they are not physically connected, because the voltage here, the magnetic field transfer or cut across to the secondary coil here by means of electromagnetic radiation. There is a mutual inductance here. This secondary coil induces voltage derived from the variation of the voltage here. Okay? This is actually the principle of the radio transmission and reception system. No? The radio transmission and reception system. We will consider this one as the cell site. In every municipality, there is always a cell site that you're always looking. You must be getting closer to that cell site in such a way that your cellular phone can get not only 1 bar, 2 bars, 3 bars, 4 bars. If there is 5 bars, 5 bars. If there is a very strong signal. But if you are far from that cell site, the signal there is 1 bar only, then it is very hard for you to use your cellular phone because it is only 1 bar. Especially 0 bar. You are very far from the cell site. That is the principle of the radio transmission and reception system. So, the signal here, the voltage here is transferred to the coil without physical connection. It is transferred by means of the magnetic field. Okay? Okay, it goes like that, class. That is to verify that the optocoupler, the phototransistor, and the light emitting diode here are not physically connected. So, the signal here, and the electrical signal, transferred to the other circuit by means of light. Once it emits light, the LED, the phototransistor, which is sensitive to light, that's why it is called photo, which is light, will be activated. No? Okay. It goes like that, class. Okay. Let us now come to the voltage controller IC. What is that voltage controller IC, class? So, actually, as what you have learned before, okay, that there is actually a switching transistor here. It is actually a MOSFET, metal oxide semiconductor Philippine transistor, that turns on and off the voltage here. There is a 325 volts here across this capacitor, which is submitted or supplied to the primary winding of the switch mode transformer. Is switch on, switch off, switch on, switch off by means of the switching resistor. It is actually mandated by the clock pulse generator, diba? As what we have demonstrated last time, it goes like this. Okay. It goes like that. So, positive, negative. Negative here. Okay. Okay, there was error again. But that was the flickering of the pulses. It pulses. When it gives light, it is like this here. When it pulls down, off, on, off, on, off. Okay, it goes like this, class. These are now the pulses. We've heard the actual pulses outputted by this pulse generator. No? On, off, on, off, on, off. Which will mandate the operation of the switching transistor. Because the switching transistor is supplied with voltage from this pulse. Okay? It goes like this. So, we have here a transistor. 1, 2, 3. Connected to the earth here. This one connected to the coil, the drain. We have here the drain, the source, and the gate. The coil here actually is supplied with 225 volts. Okay? Which will be turned on and off by the switching resistor as mandated by the pulses over here. We can consider this one as the clock pulse generator that is fed to the gate of the switching transistor. When it is turned on, the transistor will conduct. So there is a flow of current here from source to drain. But anytime that it is dropped to zero here, cut off. There is no flowing of current here. Zero. So that should be the action of the switching resistor. On, turn off, turn on, turn off, turn on. In such a way that there is variation of the magnetic field here that provides voltage at the output. Is still AC. Okay? So it goes like that, class. So there is usually voltage outputted by this clock pulse generator. So it goes like this. If we are going to measure the voltage here using AC voltmeter, we will use AC voltmeter. Okay? Negative is here. Negative is here. Then the output is here. See? See? So, the voltage actually is varying. On, off, on, off, on, off, on. Every time that it lights, there is voltage. But anytime that it drops to zero, meaning to say that there is no light. So that would be the voltage which is fed to the gate. So the switching resistor actually is being triggered by the clock pulse signal fed to the gate. Okay? So it goes like that, class. Okay. So how many times that the clock pulse, that the transistor turns on and off, that depends upon the frequency being generated by the clock pulse generator. So, because the high frequency circuit here uses frequency ranging from 20 kilohertz up to 1 megahertz, let us assume that the frequency being generated by this clock pulse generator here, it is located internally of this IC, is 100 kilohertz. It is 100 kilohertz, meaning to say that the transistor turns on and off 100,000 times in 1 second, because there are 100,000 pulses, 100,000 pulses in 1 second. So, how many pulses in 1 second here? Probably it has 3 pulses only, 3 hertz in 1 second. But if we will increase the pulses, so probably there is 10 pulses in 1 second or 10 hertz only. But the clock pulse generator here, which is located internally of this IC, can reach up to 1 megahertz or 1 million pulses in 1 second. So let us presume that the number of pulses here is around 100,000 pulses or 100,000 kilohertz, 100 kilohertz. So that is generated by the clock pulse generator here. So the transistor turns on and off 100,000 times in 1 second. However, these pulses, the width, we call this one as the pulse width. No? The pulse width. Pulse width. Okay? The pulse width is actually the time that the transistor is conducting. At this point, the transistor is conducting. But at this point, the transistor is cut off. So actually, this switch mode power supply is sometimes called as PWM. Thus, switch mode power supply. It is PWM or pulse width modulated. It goes like this, class. Okay, this is now the period 1 cycle. Period is the time it takes to complete the on and off state of the cycle. This is 1 cycle or 1 hertz. So, when we talk of pulse width, that is the width of the pulse that the transistor is conducting. Okay. Because if the voltage here reduces from 5 volts, reduces to 4 volts, so 2 volts and 2 volts here. Then the 2 volt is being compared to the reference, which is 2.5 volts. So there is a difference. The circuit is not working very well. So that will be submitted to the voltage controller via optocoupler. So there's a need of dictating the switch resistor here to work harder. So the pulse width will be increased here, just like that. So the width, this is 1 cycle actually. The duty cycle or the pulse wherein the transistor is conducting is the duty cycle. Duty cycle is the ratio of the pulse width to the pulse period. The period actually is the complete cycle, no? For the on state and the off state. But the width of the pulse width or the duty cycle, that is now the operation of the transistor which is working, is increased. This is 50%, 50%. 50% on or 50% conducting the transistor, 50% off or resting the transistor. It goes like this, class. 50% on, off, the same time for on and off. But if there's a need of increasing the operation of the transistor here because there is a decrease of voltage at the output from 5 to 4, so 2 volts here being compared to the reference of this precision shunt regulator, which is 2.5, there's a difference of negative 0.5. So that will be feed back to the control IC. So the pulse width now or the duty cycle of the transistor is increased. So from 50% it is increased to 80%. It is increased to 80%. So there's a need of doubling the operation of the transistor before it is cut off. So that increases the voltage again here. Both the two outputs are actually controlled by the pulse width. It is now the pulse width. But if in case the voltage increases to 6 volts from 5 volts, so 3 volts, 3 volts, 3 volts is actually higher than the precision from the reference voltage 2.5. So there's an increase. So that will be submitted to the controller here. So there's a need of reducing the operation of the transistor here. So instead of 80%, 20% for the rest, so we will make it 20% duty cycle or turning on the transistor and 80% for the rest. So the transistor should rest or off 80% because there was an increase of voltage at the output. So the pulse width now wherein the operation of the transistor is only 20%. So pahinaan natin ang operation ng transistor because there's an increase at the output. So that reduces the operation of the transistor. So actually it is only the pulse width is being adjusted, but the frequency retains the same, 100 kilohertz. 100 kilohertz is retained. So that is now the frequency here. But the pulse width is modulated. Actually, pulse width is modulated, or the other term is varied by the feedback signal. So it is now the feedback signal which is transmitted via optocoupler that will vary the pulse width here. Vary the pulse width. Okay? So what is the time actually? So it goes like this, class.